All right. Well, there's a whole 2 students in class today. That's exciting. MLK Junior Day is not, in fact, 2 days long. Send some invites to folks. Okay. Yeah, we'll wait a minute for people to show up. 3-day weekends, they're confusing on our minds and bodies. While we're waiting for a minute or two, great time for questions about previous lesson. Anything that wasn't clear, could use more explanation. You run into errors with any of that.
Yeah, okay. So I got pretty behind on the last assignment. So I just wanted to make sure, like, make make it crystal clear that our assignment was just to commit and push onto GitHub.
Yeah,
Okay, that's what
yeah,
I did. I got really
it's
nervous. Yeah.
yeah, you did. In fact, your README document was like a really bizarre fever dream novel or something. It was like,
Oh, it was the entire B movie. That's why.
oh, okay, there you go. I obviously didn't read the whole thing, but yeah, you had your more than 10 commits on there. That's great. Okay, so yeah, the entire first assignment was git add, git commit m, git push, just getting used to that. And basically, what it's given me, the, let me share my screen, is now I have a local stored version of your online repositories. So if I look around, I've got student repos, spring 2021. Okay, so these are the ones I currently have. If you see your name, you're good to go. I think that's everybody. Okay. So what I can do is now do a git pull. So I could go into, let's pick on Baker here, data course Baker, look around, cat readme. All right. So here's all the different commits or the different info in readme from Baker. And now I can just say git pull. And the git pull command is probably not one you're going to have to use in this class very often, except for, well, no, I think I've made it so you don't have to. What it does is it takes the online version of whatever repository you're in and pulls down all the new changes. So if I hit this and it says, okay, it'll either say everything is up to date or it'll get me the new version. So now it looks like there's been something added since I last pulled this, and it was a change to the readme.md. So let's see. Yep, now we're going to higher numbers from the previous version. We went to 10 before. We've had some extra practice, adding stuff in. We're good. So that's why that's assignment 1. Is that now I have something of yours on my computer. Anything that you commit, add, push to the online repository, I can pull down to my computer. Does that make sense?
Yeah, that makes sense.
Okay. And I've graded everything I saw in Canvas, so you should be able to go in and see. I think everyone got full credit because you just had to have 10 commits and give me your link. So that's ready to go. All right, anything else? Okay. Well, this is our last week we're going to spend in the command line like this before we move on to actually doing our studio stats and making figures and stuff. The command line's going to still be important because you need to kind of know that get syntax, push, pull, all that kind of stuff, add, commit. And it gives us a chance to kind of, in a really simple environment, see some of the things that we can do later on or with any programming language. Okay, R in our case. So let's look at today's lesson. File paths, we've covered that, but we'll do a refresher. Pipes, redirection, wildcards, and then we'll learn some essential Unix commands. Okay. So we've got resources, we've got last semester's videos, we've got remedial Unix shell, basic Unix commands, these come in handy, tutorial, and then why we do this stuff in science. The value of and annoyance of command line bullshittery. And those are actually the names of these articles. Okay. And then just kind of like a little sneak peek at if you want to go on in bioinformatics, these things are the backbone of all bioinformatics, works through the command line. And so there's these little kind of one-line cheat sheet things. You can kind of see how to do stuff. Not required, but if you're interested, look at that. Okay. And then we've got video walkthroughs of kind of the stuff that we'll be talking about here, just for another look at it. All right, so open up your terminals and go into data course your last name, and we'll start playing around, kind of seeing what we can do. Give me a digital hand when you're ready to roll. Got almost everybody. Remember how to navigate in your terminal. PWD shows you where you are. CD lets you move around and change directory. All right. So if I type in ls, you should have, from last time, a folder called data. So let's go into data. And then there's a bunch of files. Too many to display on the screen. But one of those is actually a directory called data shell. So I can type in cd lowercase da and hit tab, and that'll autocomplete to data shell. So I'm in data course, my last name, data shell. Now I can look around and I've got creatures, data, many files, molecules, all that good stuff. Okay. Somebody walk me through how to see the contents of notes.txt.
You just say cat notes.txt.
That's it. Okay. Time for your first new command of the day. WC. I want you to run WC notes.txt and tell me what it does.
So there are 3 lines, but I don't know what the other numbers are.
Yeah, good catch though. It has 3 lines. The WC stands for word count. So it tells you lines, words, and characters. And the way you would find that out is either man WC, where it gives you the manual, print new line, word, and byte counts for each file. Or you just Google it online. And there's some stuff that we can add to this. So if we do WC-C, it just gives us the bytes, the number of characters, or bytes, I guess. Then M is characters, L is lines. So I'm going to hit Q to quit. How would I get this to print out just the number of lines of notes.txt?
So will something tell us how to do that if we look back at man WC?
Yep. One of these.
Minus L.
Yeah. Little dash L. So I'm going to hit Q to quit again. WC-L notes.txt. There. Tells me how many lines were in that file. All right. Somebody tell me how many lines are in pizza.cfg. Chris, I see your hand. Is that from previous or you have a question? Previous, I guess. Okay.
Both, yeah. I
both.
can see it in when I ls my data course Nielsen, but it won't open. So
it won't open?
Yeah. Like,
Did you? Is it giving you an error?
Yeah, it says no such file directory, but I can see it in the ls. So I'm not sure what I did wrong.
You have to go into it first.
CD data?
Yeah.
Yeah, that's what I'm doing, and it's not.
All right, share your screen with me real quick. This will be good for everyone to watch along with also, because I'm guessing you're just kind of messing up the file paths.
Yeah, I think so.
All right, give me a PWD. All right, you're in users, Matthew. Okay. CD data course. All right, give me a PWD and now an LS.
LS data?
Nope, just LS. Okay, so you've got data there. So now CD data. Okay, now CD lowercase data, and then hit tab. Did you hit tab? Not enter. Now hit enter. Okay, now an LS. There you are.
So, I guess I just, obviously my bad, but why did it was up here, I was in the right directory, why did it take me out of the right directory?
Oh, because you just typed CD in the next one. That took you back home.
Oh, okay.
Yeah, so that line that ends in CD, that moved you, that's a shortcut to just change directory to my home, and that's why you were in Matthew.
Okay.
When you tried cat notes.txt before, it didn't work because it didn't see it, because you weren't in data shell.
Okay, my bad, thank you.
No worries. This stuff happens. This is why we mess around with it often and for long periods of time to kind of get the feel for why that's happening.
So I have a question.
Okay.
When I type in man WC, it just says command not found, but I can do like WC -- help and it
That'll
shows me
work.
stuff.
Yeah, it just depends on your operating system. -- help is what I normally use.
Okay.
Yeah. Now, excuse me. Honestly, when I'm programming, I just have the internet open also. It's easier for me to have, like, I've got a 2-screen setup. So on one, I've got Google, the other I've got where I'm actually typing, and so that's my reality. You can also split your screen, just have a Google open there. No worries. When we get into RStudio, it makes it easy to find the help stuff for us and keep it in the same screen. So not a problem. All right, so WCLPIZ tab will autocomplete for me. Yep. We got 3 lines there. Cat, pizza. We got alpha, beta, and gamma. Okay. So WC and WC/L, that's your first new command today. And what to do, it counts words, lines, and bytes. All right. Let's see. Everyone's got top 10 clients, right? How would I look at the first 3 lines of this file? We did briefly mention this last class period, but it's been a while, so let's refresh.
Do we use head?
Head -3. Top 10 clients.txt. There they are. Okay, how about the last one? So I just want the output to be Tori Siebert.
Bottom one top 10 clients.
Nope. What's the opposite of head?
Tail.
Tail. Tail 1, top 10 clients. Okay. Now for the real review, the brain teaser. How would I get just 1, 2, 3, 4, 5? Inga McMonigal. Just client number 5. And here's your hint. I'll give you a minute to come up with that.
So we're going to put 2 commands together then? That's what the pipe means?
Mm-hmm.
Okay.
What character is that?
It's shift \\. It's the pipe, just the straight line. On a lot of keyboards, it's right under your backspace.
So if we're putting 2 commands together, could we do like head -5 for the first part, and then tail -1 for like the end, like maybe a pipe in the middle, and then -1 for the last one of the list of 5?
Let's see. Yep. All right, so what happened here, we took the program head and we said, okay, give me 5 instead of your standard 10 of this file. And then instead of sending it to our screen for the humans to look at, I want you to pipe that. That output becomes the input for tail, where we do -1. Okay, so head top 10 clients, head 5 top 10 clients gives us those 5. I can hit the up key to go back to that and say, okay, now from that, pipe it, give me just the last one. All right. Who needs me to explain the pipe a bit more? We're going to start using it a bit more and more today and Thursday. And the R programming language also has a pipe that we'll use a lot. So this is important.
Why was it tail -1 on that one and not like tail -1, 2, 3, 4, 5?
Because the input that tail got was actually just the first 5. So head top 5, top 10 clients gives us 1, 2, 3, 4, 5.
Okay.
And then we wanted the last one of that. And so that's why. Does that make sense?
Yes, it does.
Okay, cool.
So would this not work if you wrote it the other way, like tail -1, pipe head and stuff?
No, we'd have to do tail -5 or 6, right? Because we want number 5.
Oh, okay, and then you do
So
pipe and
tail
head.
6, top 10 clients, pipe it to head 1. Yeah.
So you don't have to write top client again in the second part of the pipe?
No, and that's a good point. You don't have to, because it doesn't need to know anything more. It's already got its input. Here, we had to tell tail or head. Let's go with that one. We've got to tell head what file to look at. But then it gives us our output, which is these 5 lines. And so now tail is using that as its input. You don't need to tell it which file to use, because it's not using a file. It's actually just using the output from the previous thing on the left side, which in this case was head 5, top 10 clients.
So could you then do like another pipe and say like word count or something and just like keep going with pipes?
So word count L, how many lines do we have? 1. Yep. Absolutely.
Okay,
And so,
cool.
yeah, this is the beauty and the power of the pipe, is that we've got a bunch of really simple little programs, right? Head, that's not super useful by itself. I mean, you may run into circumstances where you want to see the first 5 lines of something, but then you can pipe it to another program and pipe it to another one. So if you learn 10 of these, you can chain them together in creative ways to do really powerful stuff really easily. And yeah, you can just keep chaining as long as you want until your computer runs out of memory. All right. So the R language we'll be using for most of the semester also has a pipe in it, which comes in handy in exactly the same way. The output from the left-hand side becomes the input to the program on the right-hand side. So head 3, top 10 clients, WCL, what's that going to give us?
The word count of the number of lines in the top 3. Right, but then wouldn't that just be 3 anyways?
That's 3. Yep.
So that almost seems like an unproductive thing to do because like
Yeah.
you're picking 3 and oh okay.
Yeah, it is unproductive, but unproductive things are a good way to learn a language like this. Like a sanity check, right?
Oh, that makes
So
sense.
yeah. So yeah, that had better be 3, or else something is really wrong with numbers as we know them, or our programming language. Okay, so how about this? I'm going to do cd ... So I'm in data with all these files. So I'm going back 1. How would I, from here, get the number of lines of pizza.cfg without changing my location?
So I know ... means go back, but we want to go like forward.
// Then WC.
We're going to get an error here. So this is relative file paths. We want pizza.cfg, and we want to send that to wordcount.l so that we can see how many lines are in it, but we don't want to have to move to where pizza.cfg is.
You have to specify that it's in data.
Yeah. So I would do wcl data shell pizza.cfg 3. All right, I need you to understand this. So please let me know if that's unclear.
So why did you not have to do the / or like cd / Why could you just put it in and it would work?
Well, because word count just wants the location of a file. If you're already in that directory, it knows where to find it because it can see it there. If it's in a different directory, like data shell, you have to tell it where to go.
So like the picture on your GitHub for this week, it has like the tree. As long as it's in the correct branch, it'll find it. But sometimes you have to move it over, or it can find it just.
Yeah, let's view this image and take a look at it. So this is showing just the root of your computer, but we can pretend that's any directory. If you were here in this top directory and you wanted to look at a file called main.c, you have to tell your computer where it is. You have to say it's in user, John, HW1, main.c. If you're sitting here and you say cat main.c, it's going to say that file doesn't exist. If you say cat user/john/hw1/main.c, then it knows the directions to that file. So that's the relative file path. See here. So when I look around, LMN, nope, pizza.cfg is not to be found where I am, because I'm in the main data course, my last name, data with a capital D. Okay. Where is it? Well, it's in data shell. So this cat command, like any command you're ever going to type in R or Bash or Perl or Python or wherever, needs directions to where the file is that you're wanting it to work on. Now, by default, so if I do cd data shell, let me clear this up. So I'm in data shell now. I can say cat pizza.cfg and it works because that's in the same directory where I am already. My little program looks around and it looks for pizza and it grabs it and it sends it to cat and it barfs it up onto my screen. Okay. So that's all well and good, but if you're in a different directory, you don't have to move to the directory of interest just to use the cat command. You can just give it instructions. So cd ... I'll go back into data, cat pizza.cfg, no such file or directory. Oh, right. Hit the up key, go back in here and say data shell pizza.cfg. Now it's going to work. Does that kind of clear it up or make it worse?
No, that was perfect. Thank you.
Okay.
So even though you're in the data folder right now, can you type data/data shell, or will it not understand that because you're already
It
there?
won't understand it. So cat data shell pizza.cfg, no such file or directory. Because looking around here in data, there is no folder called data. Right? I've got data shell, fastq16s, and messy take 2. I don't have anything called data for it to go in, and so you're giving it bad instructions. So it's kind of like if you were here in user, USR, and you said cd Jeff. Nope, can't be found. Okay. Or if you said cd TMP, nope, can't be found. Even though it exists on your computer is really dumb and it takes everything very literally, and it wants directions to get to a file from where you are currently. And that's a good thing, because it means that our scripts can be very portable. But it also means that you need to get a feel for that. You need to think of your data course Nielsen as this tree kind of shape that we're looking at here, where this is data course Nielsen and you've got data and assignments. Okay, you have to go into them to find stuff, but your computer really does need very strict instructions about how to get there for every file. Okay, so I'm in data. I'm going to go back to data shell. Okay, I'm going to look around with ls. Let's go into creatures. cd creatures and look around. We've got 2 files, basilisk.dat and unicorn.dat. Somebody tell me what's in them.
So in Basilisk, it just looks like base sequences. Or, I mean, like, it's like GACAs and stuff.
Mm-hmm. Just a bunch of fake DNA stuff. It's got a common name, classification, when it was updated, and then some sequences. Okay. Same thing for unicorn. So I'm going to just do head unicorn, so we get the first 10. Common name, classification, updated, and some sequences. Okay. How do I get how many lines are in Basilisk? Well, it's wcl basilisk.dat. 163. How about unicorn? wcl unicorn.dat. 163. How do I get the first 3 lines from each of these in one command.
So is there a separation, like a comma or something to separate the two folders?
So we could do head 3, basilisk, and then just unicorn, just with the space.
Oh.
Yep. So that's how head works. You would only know that from seeing it done, trying it, or looking through that help file really detailed. But that's, I'll just let you know that's how it works. You can give it any number of files all at once. Okay, but if 2 file names isn't that hard to type, but if there were 300, you don't want to sit there typing it. So how about this? Head 3 star.dat. Why does this work just as well?
Anything that ends in a .dat file, it's pulling.
Yep. That star matches 0 to infinity of anything, and then it ends in .dat. And so you could have 10,000 files in this folder, and if you just wanted to look at the first 3 lines of anything that ends in .dat, that would be it right there. Head 3 dat. All right, and it gives you the name of the file, and then the first 3 lines, and a space, name of the file, first 3 lines. Okay, now I can't remember, did we cover the pipe, this straight line in here yet? I think we did.
You used it, but it
was like
separates stuff.
Didn't really cover it. Okay. So the pipe, it takes whatever the output is from the thing on the left and makes it the input of the thing on the right. So I could say word count, wait, head 3 unicorn.dat, and then pipe that to tail 2. Any guesses as to what might, wait, tail 1, what might be put out from this?
It's gonna pull the updated.
Yeah. So we said, hey, head, give me the first 3 lines of unicorn.dat. Okay, well, we can do that. Here they are. Now from that, I'm going to send that output, instead of to my screen where me, the monkey, can read it, I'm going to send it to the computer program tail. So give me the last 1 line of these 3 lines. So there's updated. Okay, with that in mind, try to come up with a little command using the pipe that is just going to give us this line here, the classification Equus monoceros. Chris, got a hand.
Wouldn't it just be head 2, tail 1? Just move it up 1.
Yeah, so I'm gonna hit the up key to go back here, just kind of scroll over 2, and there it is.
So I have a quick question.
Mm-hmm.
As long as you're in the right files, because you're moving in between the basilisk and the unicorn easily. As long as you're in the right folder, you can jump between the 2, but it's just the folders that are the barriers of entry. Does that make sense?
Yeah, the barrier of entry, I guess, in the way you're putting it, all comes down to what you get with PWD. PWD is print working directory, and so in my case, that's the whole directions how to get to where I currently am. We're in data shell creatures.
So because basilisks and unicorns are both creatures, you can jump between the two of them, run commands for all of them, whatever you want to do.
Yes.
Okay, thank you.
Since we are currently in the creatures directory and they're both in there with us, they're fair game. If we were in data shell, we would have to specify that they were in creatures first. So if I go back one, so I'm in data shell now, PWD, yep. I look around, I don't see basilisk or unicorn. They're not to be found. Okay. But I do happen to know that they're in creatures, and so I could say head 3 creatures star.dat. That make sense?
Yeah, it does.
Okay.
So obviously you're way better. You could pull data just from being on your desktop, and you could just type it out and run a command. You don't have to like keep cding pwd, cd pwd. You just can type it all out. So we'll get there.
You will. As a matter of fact, you're going to get there real soon because I'm going to require that that's how things work. For all your homework assignments, for example, you're going to be in assignment 1 directory, and your data is actually going to be back 1, and so all your homework will be referencing the directory behind it, moving into all that data. That's to make sure that it always works on everybody's computer. And so, yeah, I've been doing it for longer, but the concept shouldn't be too difficult once you realize that you're going to be somewhere in your computer at any given point in time, and you can get to anywhere else from your computer from that spot. I'm going to require you to work from that spot and tell me directions to the files. All right, so how about this? I need to go back into creatures so that we're on the same page. PWD, so we're in creatures now. I look around, there's basilisk and unicorn. I would like just the common name for each of these files. How would I do that? We did it this way. Not less, sorry. Tail 1. So that's how we did it for unicorn. How would I do it for both of them at the same time?
Could you just do the star.dat?
So let's try that. Head to star.dat, and then send that output to tail 1. We only got 1. We got unicorn. We didn't get basilisk.
So I guess, could you just spell both of them out? Basilisk and unicorn?
Okay. Basilisk.dat, unicorn.dat, and we still just get unicorn.
So maybe there's a problem with the tail -1 part of the command.
No, well, I mean, it's working perfectly. It's doing exactly what it's told. There's a problem with us and our little chimpanzee brains forgetting what's going on. So we need to debug this. So I'm going to hit up again. So the head to star.dat, send that to tail 1. We're only getting 1 out. It's not the computer's fault. Almost never is it the computer's fault. Let's see what the output from head to star.dat actually is.
Do you have to do tail -1 and then tail minus 1, 2, 3, 4, 5? To do again, head, and then tail again to specify 5 rows down or 6 rows down?
Well, let's try this. Head to star.dat and pipe in head 1. You get basilisk.dat with these little arrows. Why? Well, here's the output from head to star.dat. Look at it. So if I send this output to the tail -1 command, what's it give me? The last line. Classification Equus monoceros.
Okay, so I get that we've like created this like temporary lines here, but I don't get how we would then pull out the classifications out of this list or these lines.
Well, the answer is that we can't. Not with these two commands. Not with head and tail. Not simultaneously. And that's because the input to tail is always going to be all of this stuff. And so, since we said head to star.dat, this becomes, like you said, kind of like a temporary file almost. It's not written to a file, it's not written to our screen. All it is to go into the next command since we piped it there. Well, the last line of that, the tail 1 of that, is classification Equus monoceros. Okay. So how would we get just this line here and this one? Well, we can use what's called a for loop. Who has experience with for loops before? All right, cool. Nobody. This is going to be confusing. Once you get it, you're going to not realize how anyone can't understand it. And so teaching it has proven kind of hard. Learning it was even harder, but suddenly I understood the for loop, and everyone who couldn't understand a for loop was like really dumb. Like, how can you not tie your shoes? You're not dumb. It's actually pretty tricky. Okay. A for loop is very, very, very common in computer programming in all languages. And the idea here is that we're going to execute some command or series command on everything in some set that we make. All right, so the simplest for loop for this case would be for I in star.dat do head to $i. I know this is confusing. And pipe that to tail 1. Done. So let's break this down. That gave us our answer that we were looking for. Let's see how it did it. Okay. The for loop here starts out with, you give it the name of a variable. In this case, I just chose I. This can be anything. And then you give it a set of things to work with. Okay. So for the variable name in this set, in this case, star.dat, what set did we give it? with star.dat.
The basilisk and unicorn files.
Yeah, we gave it those two files. Okay. Now the loop part of this is that it's going to go through and do all the commands that you tell it to one at a time on each one of those things in your set. So by default, it's going alphabetically. Okay. So the first time through this loop, I, the variable, was equivalent to basilisk.dat. And so here's where the meat of it's happening. So for the variable and star.dat, I want you to do something. I want you to do head to $i, the value of I, the current value of I, and then tail 1, and then be done. All right, so it's going to run through this loop twice since we gave it two things. For I and star.dat, the first time through, I equals basilisk.dat. And the second time through, what's it equal?
Unicorn.dat.
Unicorn.dat. Okay, and so it just goes through, and the value of I changes each time this loop happens. So it interprets this as we're going to do something. Okay, everybody get ready. Head to $i. That means the current value of I, and it knows what that is. It says, all right, I know what $i is. That's basilisk.dat. So I'm going to do head to basilisk.dat, and I'm going to send that to tail 1. Oh, and that's it? I'm done? Okay. So it's going to send that out, and then it says, but there was another thing in my list of star.dat, and that's unicorn.dat. So now I'm going to do that same thing, only now value of I is no longer basilisk.dat, it's unicorn.dat. And so it's going to give us that. So let me show you another one of these. The echo command will spit things out onto your screen, and in curly brackets we can say 1.10. This is just the bash way of expanding the values 1 through 10. All right, so echo curly bracket 1.10 just gives us that. Okay, 1 through 10. Now, what about this for I and do echo $i done? What do you think is going to happen here when I hit enter? When you're looking at a for loop or writing one, you need to always think about, what's my variable name going to be? What set of things am I going to give it to be equivalent to, one after the other? And then what do I want it to do with that value? So in this case, my variable name is I. The set that I gave it is the numbers 1 through 10. And then what am I having it do to each of those values?
Why do you have to put the $sign in front of I? Why can't you just write I?
Let's see.
Oh, so it takes I as being like what you're
Literal.
working with?
It takes it literally. And so
Mm.
I gave it a list of 1 through 10. And it said, okay, I is equal to 1 now. And when I said echo I, it interpreted it literally instead of the value of I. And so the $sign denotes the current value of that variable, not the name of the variable. Okay.
Do we
So
have to use Sorry, do we have to use I, or could it be like X, or could we write a word like number or something?
For your mom in 1.10, semicolon just means new line. Do echo your mom is $, your mom years old. Done. You see how that worked? We've got any variable name. I like I because it's nice and short. And traditionally it's kind of used in online tutorials and stuff. And so if you're looking for help with an error, you'll often see that kind of as the answer. And so I'd like to use it. But any variable name here will work. We give it some set, the numbers 1 through 10. We say, okay, new line, we're going to do echo your mom is $ your mom years old. Done. And so what's happened here is that it's writing this sentence for us. Your mom is blank years old. But each time through the loop, it's going to pick out the new value of your mom. And it's going to print that to our screen.
So it can figure out the $ your mom, even though it's inside like the quotation marks. So that doesn't matter.
Sure can. Yep.
Okay.
All right. What else can I help you with on this before we? I'm going to stay on the for loops, but I want to make sure we're all kind of understanding so far, at least the components of what goes into one. A variable name, a list of things for that variable to equal, and then some action for each time it equals one of those things.
I have a question. So in the first for loops, you tabbed down, and I had like, how to describe them? A little indents vertically.
Mm-hmm.
This one is just semicolon horizontally.
Right. So here, I typed an enter after this for I in 1 through 10, and it's basically saying, okay, you're not done yet. So it gives us this little marker saying, I know what for loops are, but you haven't given me stuff to do yet. And so it just kept waiting until I typed done. When I hit the up key afterwards, it put it all on one line for me, because this is how it actually read it as a computer. And so it's the exact same. We're saying for I in 1 through 10, a semicolon means new line, new command. Do echo the value of I, new command, done. And so it looks different, but it's exactly the same as this. So you can type it either way, but in your history as you go with the up key, it's always going to turn up like this. Okay. What else could a for loop be useful for? We did a complex action on both of these files simultaneously. That's kind of nice. Can you think of any scenarios doing data analysis where this would come in handy? Because it's not super useful to say your mom is 7 years old and your mom is 8 years old. No? Okay. Well, we will run into them, scenarios like this. If you haven't thought of them yet, be thinking about them. Okay. Other questions about a for loop? This is the kind of the simplest one here. The important thing for you to understand at this point is just the structure of it. It's going to be written differently in Python. It'll be written differently in Perl or R or C, but every language has a for loop and they all behave exactly the same. And that is, you give it some set of potential values, a variable name for those to cycle through, and then you do something to each of those values. So I'm going to open RStudio just as another way of showing you some of this stuff. I'll show you how for loops are written here. For I in 1 through 10, 1 plus I. Did I type that right? Oh. Print 1 plus I. And here's my output. For X in 1 through 10, print X times 2. So what's going on? Have I totally lost everyone?
You just squared each of the variables. Wait, maybe not.
Not squared. This would be squared.
Times it by itself.
Times it by 2.
Okay.
Yeah. For X in 1 through 10, I'm going to print the pasted version of file in all caps and X. File 1, file 2, file 10. So we can work with thousands of files, thousands of columns of data, all that kind of stuff with this concept of a for loop, and we can do it all at once pretty simply. Okay. Here it's just written a bit differently, but it's the same stuff. We're saying for some variable and some set, do something with the value of that variable, and then finish. All right, so let's take a look here. We get back out of creatures into data shell. So data shell, I'm going to look around, and behold, we've got a folder called many files. CD many files. Huh. That's a bunch of folders. You know what? No, we don't want many files yet. That's next up. Where do I want to be? Molecules. Okay. So I'm in data shell molecules. I look around and there's just a bunch of molecules. So we can head cubane.pdb and take a look at it. Okay. So this is information about the molecule cubane, octane, pentane, propane, all that good stuff. Now, how would I extract the author from within each one of these files using a for loop? Write what you think the answer would be and stick it up in our chat. So I want the line that starts with author, each PDB file. For INPDB, do head to tail 1. Do head to tail 1. All right, Shannon and Stephen have popped up a couple answers there. They look different, but they're identical. Let's see here. For I in star.pdb, do head to I, pipe that to tail 1, done. Okay. What about this? Do head to tail, $I, tail 1, done. Heath, you've got a typing error. You did a colon instead of semicolon after -1, so that would break, but otherwise, yes. All right, I want to hear from people that couldn't get that answer. I mean, speak now. You don't want me assuming that you understand for loops. Unless you do. Okay, because your homework assignment for this week is going to use for loops. Let's take a look at that. You should be able to get started on this. Next class period, we're still going to be kind of going through some of this stuff, some of the redirects and whatnot. But for example, for each file name that begins with M in the directory, data shell data PDB lists the number of lines in each file. I'll walk you through that one. Data shell data PDB. Oh, PDB. So we've got a bunch of files in there. For each of them that begins with the letter M, list the number of lines. Word count L gives us the number of lines of a file. M star PDB. Okay, so that's answer number one for your homework. So what we're doing is looking at this idea of getting you some practice with the wildcard, the star, and you're going to be using just a few of these little programs: head, tail, word count, and sort, that we'll go over next class period. But you should be able to kind of get started on this. And if you watch the videos, like the intro to Unix videos I've got, you'll see all the commands that we're going to be learning next class period. But hopefully this kind of makes sense to you. Even without a for loop, we're just saying any file name that starts with a lowercase m, has anything, and then a .pdb at the end, we're going to run word count L on it. So maltose has 49 lines, methane has 9, and so on. But I think you're out of time in just a few minutes, so I want to open it up to questions.
Okay, I missed how you did that, just this last part.
Right here?
Yeah, or go right above it, right before that. What did you...
Oh, that was just an ls. So I'm in data shell, data PDB. And so if I list all the files in here, you'll see all of these.
So did you change your directory to PDB?
Yeah, I did.
Okay.
That was, I went back from the molecules and then forward into data PDB, like that.
Oh, okay, that makes sense.
Yep.
Very good.
So you don't have to do CD on separate lines, right? I can do CD data, hit enter, and then CD PDB, and that would work. Or I could just say change directory to this path. I want you to go forward into data and then forward into PDB. So this is how your scripts are going to run it, and you'll see that once we get into R for sure.
Okay.
But did this part make sense? The M star PDB?
Yes.
Okay. Yeah.
So next part says to redirect it. So are we just doing the move or the copy option?
We haven't really talked much about redirect. You've only seen it. It's in the videos, and we mentioned it in a previous class, but it's that greater than. So instead of sending the word count of all those M lines to our screen, we can redirect that to a new file named whatever we want. So now when I list, I'll have new file right there. And the contents that normally would have gone to our screen have gone to that file. So that's the redirect. We didn't have time today to get into that, but next class period we'll spend quite a bit of time with redirect and pipes. Because the idea here being that we can chain together a bunch of simple commands with the pipe that actually give us pretty complex output, and then send that to a file. So it's done. We've got it saved, and we could then use that file to analyze or whatever. But the reason we're doing this here in the shell is to get comfortable with the idea of a for loop, file paths. So why is it that from here in data shell I can say cd data pdb in one command like that and it works? That idea of the relative file path, directions from where you are. I want you to be real comfortable with those so that once we get into the R coding, we can access everything really easily. And then learning how the pipe works, how you can chain things, the output from the left becoming the input to the right becomes really important for us, along with wildcards. Well, we're out of time. I'll stick around for a few minutes. If you don't have any questions or concerns or whatever, you're free to go, and I'll see you Thursday. But I'll stick around. Anyone else? All right. See you Thursday.